Morning, friends. I am going to talk to you today about scale drawings. This is chapter 6.6, and I need your books open to page 312, where you can see the book definition for some of this vocab. Scale drawings, most all of you have seen a scale drawing, maybe the blueprint of your house plans, the house where you live. Certainly you've seen model airplanes, model boats, model cars. These are all examples of proportional thinking. So scale drawings and scale models is just another great way to use proportions. So a scale drawing, as you can see on page 312, is a two-dimensional drawing, meaning it's got a length and a width. So this is page 312. It's a two-dimensional drawing that is proportional to the object it represents. Proportional, not writing very well today, to the object it represents. Now, obviously, the scale drawing is smaller than the real deal, but the sides are proportional. All of the dimensions are proportional. The scale gives you the relationship between, catch up here, the relationship between the drawing or the model and the actual item. And again, these definitions are on page 312, along with some examples. Finish that up. So on page 312, you might see something that's familiar to you from social studies. There's a map of the town that I can't ever pronounce. Miss Cavedo has to come in here and pronounce it for me, but you can see it's giving you an old-timey map of that village, and then you have a picture of it, an actual picture of it in the bottom left-hand corner. So let's talk about scale. Let's talk about setting up some proportions. So if something has a scale of 1 to 50, what does that mean? Well, it means that the model or drawing I should say on the model or drawing, 1 unit represents 50 units on the actual real-life representation, on the actual object it represents. And we can write that proportionally. We can write that 1 to 50, just like that. So this would be 1 unit on the model goes with 50 units on the actual. Now, where did the units go? There were units there, but they canceled out because they were the same. So if 1 inch on the model represented 50 inches on the actual, we could cross the inches out because they're the same, and you end up with 1 to 50. So that's where the units went. They were the same, so they canceled. Now, in this example right here, we've got inches and feet. So if we're asked to write these as a ratio without units, we've got to turn those feet into inches so that they can cancel. So we have 1 inch to 12 feet, and there are how many inches in a foot? 12. 12 inches in a foot. Feet cancel, and we end up with 1 to 144, and those are inches. They cancel also. And now we've rewritten this particular scale, 1 to 144, without units. Let's do inches to yards. We'll have to do a double conversion here. 1 inch to 20 yards. Start with what you know. Let's do a multiplication. Let's get rid of our yards first. Yards. So 1 yard is 3 feet. So the yards cancel. And now let's get rid of the inches and the feet all together. So we have 12 inches in 1 foot. So we can cancel out the inches, top and bottom, cancel out the feet, top and bottom. The yards are already gone. Now we just need to clean it up. What do we have in the numerator? 1 times 1 times 1, which is 1. In the denominator, we have 20 times 3, which is 60. And 60 times 12 is 720. And our units are gone. Let's do a couple word problems. A map. Y'all are familiar with maps, I hope. We're going to actually do an activity with maps when I get back. The map uses a scale of 1 inch on the map. This is the map. Represents 5 miles in real life, in actual. So, 2 towns on the map are 4.5 inches apart. How far are they? How far are the actual towns apart? So we're going to set up a proportion. We're going to write our S statement. The towns are blank miles. Write your unit, the bigger unit, apart. We're going to set up our shell of our proportion. We're going to write down what we know. 1 inch represents 5 miles. This is on the map. This is actual. So over here, we have to have the map in the numerator and the actual in the denominator. So let's see what it says. 2 towns on the map are 4.5 inches apart. That's up here. 4.5 inches on the map. How many miles in actual? So now we're going to write our proportion without the units. We're going to make it a math problem. 1 over 5 equals 4.5 over x. Let's see if I have a calculator handy to get this. We cross multiply and we get 1x is equal to 4.5 times 5, which is 22.5. We go back up, we fill in our S statement, and the towns are actually 22.5 miles apart. All right, let's do another. Mike's map shows a bicycle route that's 112 miles long. On his map, the distance is 14 inches. What's the scale of the map? So we're actually being asked how much. The question here is, if 14 inches is 112 miles, we want to know how many miles per 1 inch to give us the scale. So our S statement would be 1 inch on the map represents blank miles on actual route. So if you're looking at a map, that's different than actually getting on the road and going yourself. So we're going to figure out what the scale is of this map. So we can replace that with an x. That's what we're looking for. And we get 14x, cross multiply, equals 112. Divide both sides by 14, and we get x is equal to, let's see what I got here, 8. So basically, if you measure 1 inch on the map, that's telling you that in real life, in actuality, that distance is 8 miles. Let's set up another one. The model of a sailboat has a scale of 1 to 20. Now, they're not telling us the units here, But down here they tell us the actual sailboat is 32 feet long. So that means 1 foot represents 20 feet. How long is the model? S statement. The model is blank feet long. Since it's a model, we expect it to be less than the actual sailboat, so we hope that works out well. We're going to set up our proportion. We've got feet and feet and feet and feet. That's not going to help us much. We need to write the word model and actual. So the model, 1 foot represents 20 feet to the actual. And what do they give us over here? We need model in the numerator because I started in the numerator over here. Actual right there. They tell us the actual sailboat is 32 feet long. That's where my X goes. Let's write it with no units in order to do the math, to do the cross multiplying. 20x equals 32. Divide both sides by 20. I'll go up over here, hop on my calculator. 32 divided by 20 is 1.6. So now I got to go back up and see what I was answering. The model is 1.6 feet long. So the model is not very long compared to the actual sailboat. Let's see what we have here. Actually, I think you can do this one on your own because it's just like the last one. And you can do number 5. Let's look at number 6 together. The gardener is making a scale drawing of a garden. The length of the actual garden, there's our key word, is 9 yards. The length of the drawing is 3 inches. Find the drawing scale. So what do we have? They give us 9 yards actual represents 3 inches on the drawing. So we want to know how many yards does 1 inch represent. That's what it means when it says find the scale. It's a unit rate that we're looking for. So if we cross multiply, we get 3x equals 9, or x equals 3. So in answer to this first question, we get 1 inch represents 3 yards. You can kind of have done that one in your head. Now it says, so let's write that down here. 1 inch represents 3 yards. This is 1 inch on the model, represents 3 yards on the actual. But now it says write it without units. The only way I can write it without units is if I can get these guys to cancel. And I know I can get from yards back to inches with a couple conversion factors. So let's look at what we've got. We need to turn the yards into feet. So 3 feet, 1 yard, the yards will cancel. Now I got to get from feet to inches, just like we did in an earlier problem. 1 foot is 12 inches. Now my feet cancel, but also my inches cancel. So now I have no units, which is what they're asking me to do. Multiply straight across. 1 times 1 times 1 is 1. 3 times 3 is 9. 9 times 12 is 108. So this is the scale without units. Please look at this video a couple times in order to be able to do your homework and fill in these couple problems that we left out. I think that was number 5 I wanted you to do, and also number 4. And I'll look forward to talking to you about it when we get back, and maybe we'll do some work, like I said, we'll do some work with maps to see if you can find your scale and on your map. Okay, have a great day. Bye.